Hello everyone, my name is Anand. I do machine vision application and software development. In one of my previous tutorial, I've listed out the steps to easily install and run YOLOv version 5 object detection framework in Jetson AGX Xavier. And following from that tutorial, I want to take it further, and in today's tutorial I will show you how to integrate the custom cameras other than the USB cameras, so you can do the detection on the custom camera feed. So let's start from here. I'll close the browser and go to the terminal. So I'm running everything in the max mode. I'm on the AGX Xavier developer kit, and so show you the camera I'm using, that command. So today I'm gonna demonstrate this tutorial based on this camera. This is the Basler ACA2440 USB camera. So the Basler has got two kinds of cameras. One is Gig E camera, so that's based on the Ethernet, and that has got the IP address, and so you can stream it and you can browse the stream based on the IP. And but this one is the USB camera, and I put those in a camera housing. So there you go. So what happens is when you go to this, I assume that you have already installed the YOLOv version 5 and it's up and running on your computer. So the main file, this detected by, which comes with the YOLOv version 5, is the main file that does the inference. It's pretty easy. So if you see, whenever it's a webcam as a source or input to the YOLOv version 5, it can also take the streams such as HTTP, RSTP, and RTMP. If you go and if we run the command ls USB to list out the USB devices connected to my computer, you can see there's two Basler cameras and one a normal Microsoft Livecam HD webcam. But then you issue another command, that is ls -la /dave v4l, and if you want to see them by ID, you can see just the USB, the webcam, but these Basler cameras are not listed here. So if you just run the YOLOv version 5 and just say source equals source is 0, that's the index of the camera you are going to use. If it's just a one single webcam, it's going to be index 0. If there are multiple, it can be 0, 1, and 2, and 3, and 4, and like that. So you just provide that index. That's what it is saying is a video 0. So it takes that one. So if I go to series space YOLOv5, and then I say okay, I want to do some detection. So that's Python 3 detect that by source. I specify source 0, and that will grab the stream from my webcam. So that's the current resolution. It's a bit slow to start, but once it starts, it's good. So that's the YOLOv version 5 running on the AGX Xavier at the moment. So it's doing 10 frames, how many frames? It's doing 30 frames. So that's a real-time detection. on the default inference resolution. So it's a problem. I want to force quit it. Sometimes it happens, but then you have seen previously, since these two Basler cameras are not listed in here inside this V4 YOLO, you can't index them, and you can't take that as the directly stream, or you can't use those directly to the detections. So normally, even the Basler cameras, or if you go with the Kinect cameras, it's the same thing, because they have their own separate drivers and install their SDK, and then you can read their stream out. So what I want to do here today is, if you use the SDK or the library provided by the custom cameras, the Basler, then if you want to use that, maybe you have to modify a lot of the code inside this object detection framework, the YOLO version 5, or even if you use the other YOLO version 3 or any other implementation, you have to go and you have to modify, because this is someone else's code, and that's you have to go into their code, you have to change it, and maybe not just in one file, maybe a lot of files. So the trick now is, you have this, so if it can read from a stream, so why not stream the Basler USB cameras, and then we read the stream. In that case, we don't need to modify anything of the YOLO version 5, we just provide the path to the HTTP stream. So I'll show you this way this trick works. So let's go have a look. For that one, I have to start with a basic script. So I've got this script here. This one, maybe this one. So to run the Basler camera, you have to install the Pylon library. So it's a Python version of the Pylon library. So that's Pylon, and you import the package, then you create an instance, and it will just create an instance for whatever first device it says. So if you have two connected, it will just go for one, whatever it says the first, and then you open up the camera. You specify the pixel format. It can be RGB8, or there are several pixel formats available, but I think with the OpenCV you go with the BGR8, because OpenCV reads as a BGR channel. Created a window, and in the OpenCV I resize that for a viewing, like a good view, like a small window. So now you start grabbing the frames from the actual Basler camera, you convert it into an array, and then so here is a bit of channel conversion, RGB to BGR, and you show it, you display in that one. So I'll simply run that one. So maybe let's see what happens. So where is it? So I'll create a new terminal. So it's in the desktop. CD space desktop. So Python 3 run Basler simple deploy. So that's the Basler camera. So you can use the OpenCV to read the Basler stream. Escape to close that window. So this is just a basic script. Now I'll close that one, and I'll show you how to stream that out. So this is a text file. So here you go. So in our case, we're using the Flask library, to the Python library Flask. to stream the images coming from the Basler to the so we can view in the web page. So let's see. So we read the video because that's just a webcam. We are doing it for the webcam at the moment. So I can say CB2 that video capture. So that's going to capture my webcam, and that's the default one. Don't worry about this. So you go to that function, you just read the video. If it's successful, you encode that the JPG is image, so each frame will be an image, and then you yield that. So you encode and yield that. So it's just like if you browse the Flask basic examples, you will know that for some reason that was not working for me. So this is a working one. And this is a part inside this main road. That's a main index, and this is a swap index. So also what this means, so you can have this like a cam1, cam2, or whatever you want to type here. It's just a route. So then you are streaming out, you can use just this line here. So you run that one on your host. It's a local host. You can specify that, or if you don't write anything, just these two inverted commas, you will just go with the local host, and that also means the local host. You want to select some port, so I'm using port 5000, and write it equals true. So if you just run this one, you can stream the webcam, so you can view it in the browser on that IP address, or that's the local host anyways. So but whenever you run this, it says sometimes complain this is on a developer environment and not a production environment. So if you just want to get rid of that one, I think that will just if you use this as is, it will just service one request at a time. But if you want to go into the production, you want the multiple request gets accepted, you can install another package called G-Event. That's what it is here, and then you import the WSGI server. So that's the server you want to run on port 5000, and you want to run this thing here, and then start the server. So basically you can just go with this line only, or if you want to just go everything in the production line, you can just replace that line with this, but you install this G-Event. Okay, so let's see. Python 3 HTTP stream webcam.py. So now it started streaming. So if I go into my web browser, and if I go localhost 5000, just say, if you go and just that one, you see a default message. That's what you have written here, but you want the video, you want the stream that's in here. So if you have the video feed, just say go, I want that video feed. Sorry, let's get back here, video feed, and then you can see me. So this is the webcam. I can close it now. So I think you have understood these things. So how you gonna stream out the webcam. So we do the same thing, but for the Basler cameras. So here is the Basler. So it's the same thing. You have the Python library. So instead of the video capture that you use the OpenCV for the webcam, you have to go with their library and you open up the camera. So I'm putting in the BGR8 for the channels, and it's the same thing. And while true, instead of video to read, you will grab the frame from the Basler camera, convert it into an array. If you want to resize it, you can resize using the OpenCV function. Otherwise, you can stream whatever the frame is with the original aspect ratio. And this is quite unnecessary, but I have put the date and time so I can see the timestamp using the OpenCV. And the last thing is you convert it into bytes, the frames into bytes after encoding, frames into bytes, and then you yield that, go here, and then it's the same thing. What we did is this one we are streaming it on port 5000. That's all. So let's run this. So we kill this previous webcam thing, and we run this Python 3 http stream Basler.py. So this will open up one of my Basler camera, which it finds first, and then stream out. So let's go. Let's look in the browser. So it's the same port where we're streaming it, but it's just a different camera. So localhost video feed. So this is the Basler camera, and you can see the timestamp here. So this is the timestamp I put using the OpenCV function. I'll close the feed. Okay. Yes, but it's still streaming, so I've used that code. It's still streaming in the browser, so I want to use the Basler, the YOLO version 5 to read the stream. So for that, what happens is you can go now you have to change the source. So you can change the source to be http 127.0.0.1, I guess, port 5000, and don't forget to have that extra video feed, video feed. Hope that will work. Yeah, I think that should work. And the other thing is, if you go into the YOLO version 5, you can create a txt file. So you can have, okay, so that's running on the Basler camera. So it's doing 29-30 frames a second. It's nearly a real time. But the problem here is escape Q. Quit that one. Yeah. The problem here is we have found, like, whenever you stream, instead of directly reading the frames, you are streaming out and then you are reading the stream. So there is some latency in that one. So I've calculated the latency to be a 0.02 seconds. So depending on your application, it might be it might be a bad thing, or it might still work for you. It totally depends. So instead of specifying that on your command line, you can have a text file here, so where you can specify the stream, and you can supply here instead of doing this, because it's already in that file. So you can say stream streams.txt, so it will read that file and this file and just go and grab those. So you can have one, or you can have multiple. So if you have multiple cameras, you can list them here, and it will just go and grab. The good thing about the YOLO version 5, the PyTorch implementation, is that they have the multi-threading in use. So if you have multiple cameras, it will still do produce multiple windows and do the detection. So you can have multiple ones. Or you can run it a different a separate programs, or you can just run everything in one program. So from there, what I want to show you is let's go with the multiple ones. So now what I will do is I will strip out one of the Basler in the port 5000 and the other Basler in the port 5001. And then do the detection from using the YOLOv version 5. So let's have a look. So I have a script where I modified the previous examples, and this one, what you can see is, so basically the library, this is the Flask thing, this is actually where we are doing the streaming, format the same, grab the same. So created a function to stream out, so it takes the camera in and the name of the camera and the port. So you go in there and it created, I'm creating a multi-threading, so I create a class called my thread, and then when I run this one, so it will just call that function for each of the cameras. So if there are multiple cameras, it will call this function, and by that name of the camera instance and the port number. So each Basler camera is, if you want to specifically grab the frame from the particular camera, you have to specify using their serial ID on their hardware, and you can grab the frames for whatever camera you want. So I've got these two cameras on their camera box. So these are just the cam initialization, number of device 0 for the initialization. So now it tries look for, it enumerates the number of cameras. If no camera present, says device not connected. Otherwise, if there is any, it says how many devices connected, and then it looks for it extracts the serial number from the camera and tries to match with whatever I have in here. If match is found, it will just go and call that function to stream the frames out. So if there is one camera, so it goes, say cam1 is go and create device with that serial ID, name it as cam1, use port 5000, and run that thread. And if there is another, just do the same thing with cam2 but another port, and that's all. So if I run, if there was any other, okay, so close that one, and I'll run this multiple camera file. Oh, sorry. Python 3 http stream Basler multiple by. So connected two cameras and started the threads for the two cameras. So if I go in the web browser, hopefully localhost, that's one feed, and localhost, that's the other one, and I put 5001, I think, yes. So that's the one camera, that's the other camera. So there are two Basler cameras, and I've streamed both of them, two different ports. Now you can go to the terminal and you just run. So now this time, see, I've specified source as streams.txt. So in here we have this, two as the input. So two streams. You can see here this is the 5000 and this is 5001. Hit the run command. So this, it was successful, 25 frames per second for each of the cameras. So now you can see there are two feeds, two detections. So this is one on 5001, these on the 5000, port number, it's localhost. So the Jetson AGX Xavier is doing multiple a multiple inputs. So this is a separate camera and this one is a separate camera. Both are Baslers. So let's see the frame rate. So normally it's doing 20, 19 frames per second for each. Let's close that one. Okay, so I think that's all for today's tutorial, but I will go into this file and tell you a little bit more on what you can do from here onwards. So that's detected by, that's the actual file for doing the detection using the YOLO version 5. So here you go. Inside the detect function, I added some of my own code to create a video writer using the OpenCV. So that's the video writer function to write the videos if you want to save the detection videos. So why we need this is because if this YOLO version 5 recognize the source as not a webcam, but if it's a source as a video, then only it allows you to save and write the video. But at this moment you are using the webcam, not the webcam, or maybe the webcam, or sometimes maybe the custom camera, the Basler camera, as an input to the YOLO version 5, and then you won't have the function. You don't have the function to save the detection video or the actual original video. So then you have to implement your own code. So I created these lines of code to say create a video writer class. Then because if you are if it's a webcam input or it's a camera input, then this will be true. This will be true, and now this will be true. This view image will be true, so that it will draw a OpenCV window, and then it just like displays whatever the detection is on the window. So here I have written this line of code to write the detection out using the video writer. So that's the actual video writer. So if you do it inside this thing here, it will work for the webcam as well to save the video. So if I set it to true, that's my code, but if I set it to true, and what I'm doing here is every 10 seconds create a new video. So sometimes you don't want the large videos, depending on the application. In my application I want to create multiple small videos, so they won't get corrupted, and that's for the same reason. So that's why I have this timing thing, but otherwise it will just be out.write on the video writer to write it, but it should be inside this one because you are doing the webcam, not the video. Where if it was a video, it will go down here and you will have the function to save. Okay, so that's the thing. Now let's go to detected file, YOLO version 5. Close that, close without saving. I'll close everything. I'll go to the, so these are the previous videos, sorry. I will not be, just delete those previous ones. I just want to make sure for the last time that I done on the video saving for myself. No, so true. Save that one. And we are still streaming, so I can go straight and do the detection. What I do is, I'll close that. I'm not sure. I'll close that one first. I'll stream only one. I don't want to put more load on the AGX, so I'll stream one. So that hasn't streamed out. I want to just do only one. So I'll just save that one, and I'll go ahead and do the detection. So it'll just read that one, and if you go here, once it's running, you can see the videos being saved somewhere here. Okay, so that's the detection, and it started saving the videos. So every 10 seconds from the start, it will save the videos. So I can stop this and I can show you the videos. Is there a problem? Could be a codec problem. Wait, maybe with the VLC. There's some problem. Anyways, this shows how you do these things. Stream out the camera frames and you do the detection on that one. The easy way, it's the easy method. So I think that's all for today. If you have any comments, you can just comment it on my channel and I'll just reply to those comments. I think you have enjoyed it, you have learned something. Thank you.